Welcome back, class. Thank you for joining me for our final note video of the chapter. So today we're going to wrap up. We're going to do slightly more complicated examples of rational equations. All right, so when you have rational equations with quadratics, make sure you factor first because you don't want to over multiply. Then again, you always want to check for extraneous solutions. So what I mean by that is look at these examples. Both of these examples have a quadratic that can factor. What I mean by that is this piece right here, this is r minus 2 times r minus 5. Okay, so I'm going to factor that piece just like that. Because now I'm going to prevent myself from over multiplying, over canceling. So if I look at how I can get rid of these denominators, well, now I can see all I have to multiply by is an r minus 2 and an r minus 5. That will eliminate everything in my denominators. So that's what I'm going to do. I'm going to multiply everything by r minus 2, r minus 5. All right, and let's take a look at what happens. So in this one, the r minus 2 cancels out, so I have the 1 and the r minus 5 left. In this piece, the r minus 2's cancel and the r minus 5's cancel, so all I have left is 1. In this last one, the r minus 2's cancel, so I have a 6 and an r minus 5 left. So again, that's the power of these least common denominators. It's now I've completely eliminated the denominators, so now all I have to do is solve this linear equation. So distribute the 1, r minus 5 plus 1 equals, now I distribute my 6, 6r minus 30. So when I combine them in like terms on this side, that negative 5 or plus 4, or sorry, negative 5 plus 1 gives me a minus 4. So now I'm going to subtract my r from both sides. Add 30 to both sides. And divide by 5. So I get 26 over 5 is my r value. And if you look, there's no chance of dividing by 0 using that. All right? Plug it in. The only pieces in the denominator are r minus 2 and r minus 5. So 26 over 5 is not going to make us divide by 0. So we are sitting just fine right now. All right. Our next one, again, we have to factor anything possible. So I'm going to factor that and use that instead of the x squared minus 9. Remember, difference of squares. So now when I'm looking at this and I'm trying to see what do I multiply by, well, I think you can see that to get everything out of the denominator, I need to get the x minus 3's out, and I need to get the x plus 3's out. So I have to multiply everything by both of those pieces so I can eliminate those pieces of my equation. So let's take a look at what happens. Well, in our first one, the x minus 3's cancel. So I'm left with an x and that x plus 3. In the second one, the x plus 3's cancel. So I'm left with an x and an x minus 3. Oh, I'm sorry. There we go. Then in this one, the x minus 3's and the x plus 3's cancel. So all I'm left with is that 2. So again, by multiplying by that least common denominator, I've eliminated all pieces of the fraction. So now I'm just ready to solve. So I get x squared plus 3x when I distribute that. X squared minus 3x equals 2. Now here when I'm combining like terms, well 3x minus 3x just cancels out. 2x squared, or x squared plus x squared gives me 2x squared. So now I need to divide by 2. So x squared equals 1. Now, this is one of those times you have to remember stuff way back from earlier chapters, because you need to remember that when you square root this, don't forget, you get a plus and a minus. And when you square root 1, it's just really nice because it stays 1. So you get your two solutions of plus or minus 1. And in this case, we check both of those work because neither one of those, plus or minus 1, will make me divide by 0. So both are legitimate solutions to that equation. All right, moving right along. So here, now this one is actually kind of going back to those easy cases. This one is going back to one that you don't even have to factor to solve. So just make sure you remember, even though we get more complicated, don't forget how to go back to the basics. So here, the basics for this one is that all we have to do to eradicate those denominators is multiply both pieces by x plus 2, x minus 2. X plus 2, x minus 2. X plus 2, x minus 2. All right, so don't forget how to go back to the basics. And this one, the x plus 2's cancel. So left with 2 and x minus 2. And this one, the x minus 2's cancel. So we have x and x plus 2. Then over here, nothing cancels. So we have x plus 2, x minus 2. You could start multiplying by that 1, but I think you can already know that that's insignificant. We don't really have to show that. All right. So again, now we have something without any fractions that we're going to be able to solve. So I'm going to distribute that 2, get 2x minus 4. I'm going to distribute that x to get x squared plus 2x. And now that can be FOILed. When you FOIL it, you get x squared minus 2x plus 2x minus 4. All right, so now on both sides, let's combine some like terms. 2x plus 2x, well, that's going to give me 4x. Here, 2x minus 2x will actually just cancel out. Now here, notice, I have x squared on both sides. So if I subtract x squared from both sides, those actually end up canceling out. I have a minus 4 on both sides. So again, picture adding 4 to both sides. That's going to cancel out as well. So all I have left is that 4x. Then I have nothing left on my other side. Everything canceled out. So now if I divide by 4, that's going to give me x equals 0. And that is going to be my solution. Now again, it's always a good idea to go back and check. Well, no, that won't make me divide by 0, so it is a legitimate solution to our equation. And that means we are done. All right, now I'm going to save this word problem. I think the word problem will be easier if we do it together in class. So I'm not going to include that piece on the video. I'm just going to wrap up here, and then together in class we'll do the word problem so we can have a good conversation about it. So Please make sure you have everything written down except for the word problem. Come back to class, we'll do it together, and you'll get your practice time.